All right, welcome to the second arcade game, the Snowball game. This one is closely aligned to the classic battleship game, where you have um, a set of targets that you're trying to defend and also attack a set of hidden, unknown targets that your enemy has. And so it's exactly like Battleship, except it's like a snowball fight. So you're attacking their forts, and they're trying to attack yours. I believe there's 5 forts per side. So, um, but it's not just about playing the game. It's about a certain element that is necessary to cheat at the game in order to win. So this challenge, actually, the real background to it or purpose for it is to teach the student or the competitor the security implications behind pseudo random number generators and how they can be broken from a security perspective, in that you can generate and predict what those pseudo random number generators are going to output. So if you're unaware, computers use what are called pseudo random number generators to come up with to create randomness, essentially. So like how your password manager creates a random password for you to use, or if you're programming code and you need to have a generate a random integer between 10 and 20. Yeah, cryptography uses a lot of pseudo-random number generators. But anyway, so this game uses a very common pseudo-random number generator, and it's written in Python. It's using the Python one, which is called, or it's based on the Mersenne twister algorithm. And this algorithm, as we'll learn from one of the talks, can be essentially broken from a security perspective, in that if we have access to the prior 624 or more values that the number generator has outputted, we can predict the next value that it's going to output. And we'll see how this is useful in a few minutes, in that it allows us to win the game at the highest level of difficulty without any guesswork whatsoever. So we can essentially cheat. And this just really makes people aware of, even if a pseudo random number generator is statistically sound, it might not be secure. And so, this, as cybersecurity professionals, this is important just to be aware of, especially if you end up developing code that relies on randomness. It's an important thing to be aware of. So let's get right into it. Enough talking here. Well, I'll be talking more, but let's actually do some hacking here. So this challenge is located on the talk floor, and it's in the speaker unprep room. So if you haven't gotten into this room yet, go ahead and watch my video on the speaker unprep challenge. But once you do get into this room, you'll see the arcade game in the corner, and there are several hints for this challenge, which we will take a look at real quick. So first of all, it says, instead of launching it via the arcade by clicking on it, you can go to this link. And then that'll just launch it without the overlay. It'll directly to the game. Here it says developers see pseudo-random number generators. Okay. And this links to the Python random library, which uses the Mersenne twister algorithm for its core generator. We've got this one here with the link to Tom Liston's talk about the MT19937, which uses the Mersenne twister algorithm as an implementation that Python uses and is widely used. So this, if you haven't seen this talk, definitely give this a watch. And then we've got this final one here that tells us it uses the Mersenne twister algorithm to generate values after seeding it. Yeah, given enough data, an attacker might be able to predict upcoming values. And then it links us to this GitHub repository, which is a MT19937 predictor. So given the preceding 624 generated numbers, we'll be able to predict the next value. Now, I will say that I'm personally pretty new to this and understanding it all. I won't be able to explain in this video, how the math behind, this implementation, this algorithm exactly works so that we can predict the next value. This is more, explaining how to complete the challenge. Understanding that this sort of number generator is exploitable. So if you're looking for a discussion or explanation on the mathematics behind the random number generation and why that's insecure, definitely check out Tom Liston's talk, and I'm sure there's a lot more resources online for this specific number generator. But anyway, so given what we know, let's jump into the game, take a look at how it works, and then know that the objective for this is winning on the hardest difficulty, which is impossible. So let's go ahead and launch this. I'll just show you without the hint the way you can find out that this is in another website. You can come to sources here on developer tools. We see a reference to snowball2.kringlecastle.com. So I can just show you what that looks like. It just loads the game directly in your browser rather than like an iframe or whatever this is. All right, so we've got easy, medium, hard, and impossible. It says here, you and an opponent each have 5 snow forts, but you can't see the other's layouts. On easier levels, you can pick your own name. So I can put Dan, and I can put whatever I want here. On hard and impossible, we'll pick for you. On the impossible level, we won't even show you the name that they generate for us. And in fact, we'll throw away hundreds of random names before starting. So that's an important hint there. Okay, so let's just go play a game of easy without any hacking. Just play it straightforward just so we understand what's going on. So here we can see we've got the enemy's board and our board, just like Battleship. We've got our forts here, our targets that we obviously don't want the enemy to hit, because if they get all of them, then we lose. And if we get all of theirs, we win. So you can click on any of these or just type the coordinates down here and then hit fire. And if you hit enter, it'll essentially do hit the buttons for you, so it's a bit quicker. So then the computer missed, we also missed, and we'll just keep going through and playing the game. So I want to hopefully rather quickly, man, I'm not having too good of luck. Okay, I want to win this game just to show you what it's like. So when you have a light red square, that means that there's other squares that can be hit, and when all those squares turn dark red, you know that complete fort has been destroyed. So I'll show you what that looks like. So light red, light red. Okay, now it's dark red here, so this is one fort. So now there are 4 forts remaining. This is still light red, so this is another fort. So let's look up here and down here. Okay. Okay, so now this fort's down. So now the enemy has 3 forts left. So we'll keep going through the game. Here's another one. All right. 2 forts left. Okay, 1 fort left. Let's see here. Up here maybe. There we go. All right. And then, so this one will probably, once I hit it, will have us win. Now, one thing I will say is if you just kind of try and remember where these targets are, if I were to go and launch another game with the same name as Dan, eventually you'll notice that the enemy's layout is exactly the same. And that's because it is using that player name value as the seed to the random number generator. So we end up getting the same values here. Or excuse me, it's not necessarily using that as the seed to the pseudo random number generator, but it's using it as the seed to lay out the values on the board. And in the easy and medium levels, we get to pick that name. In the hard and impossible levels, that is determined by the game, which uses a pseudo-random number generator. So let's go ahead and win this game. That's pretty much all there is to it. And if we come back here, we can start again. So hard and impossible, we cannot choose a player name. If I go and launch impossible, you can see that I don't even get to see what the player name is. So I couldn't just take that, copy it into an easy game where I, if I knew the name, I could paste that into the easy game, figure out where all the tiles are, then come back into impossible and just win it because I know where all the forts are. But I will say that that same tactic is what we need to do in order to win the impossible level, because as you step up from easy to impossible, the game gets, the enemy gets better and better at being able to predict where the forts are. And it's a bit unfair, but in the impossible level, the game, your enemy knows exactly where your targets are. So that being said, you cannot have any sort of misses when you're solving against your enemy. Otherwise, they will overtake you and win every time. So we need to be able to know exactly, or get super lucky, which good luck. But we need to be able to know exactly where our enemy's targets are to even win the impossible game, which is how you win, complete the challenge. So, kind of skipping ahead here, but I was playing around, and eventually I was looking at the source code for the page, or viewing source, and I noticed that there was the following. So down here we have seeds attempted, and it gives us a long list of some seeds, followed by down here it finally says, here, I'll just copy this out, copy element, come into Visual Studio Code here, eventually ending in redacted perfect. Okay, so we need to figure out what that redacted value is, take that value, and then play a game on easy, figure out where all the targets are, save that, and then go back into impossible, and essentially play that game through. And what we'll be able to do is launch multiple instances of the game at once. So we will launch an impossible game, extract, figure out a way to get the redacted value. Then in another tab, we'll launch the easy game, copy that value into the easy game, play it through, take a screenshot of all the targets, and then we'll close that tab, come back to our impossible tab, and then we will play that game, and we'll know exactly where to click to hit all of our enemies' forts. So how do we get this redacted value? Okay, so if you watch the talk, Tomlinson talked about how Python uses the MT19377 pseudo-random number generator, which is the Mersenne twister algorithm. And this is susceptible to essentially an attack where if you have the preceding 624 values, you can predict the 625th value. And you'll notice that if we clean up this output in the comments, we have exactly 624 values here. So one of the hints, as we saw earlier, I think I opened it, as we saw earlier, leads to this GitHub repository. So this was just in the hints that we had received for this challenge. I think Tomlinson's talk might list it too. But anyway, this is a GitHub project that has an implementation of a predictor. So you feed it 624 values, it's going to output the 625th value. So this is exactly what we need to be able to predict our player name seed for the impossible game. And then, like I said, we'll take that into an easy game, play it through, and then essentially cheat, coming back to the impossible game and knowing exactly where to hit. So what we can do is, I'm going to go ahead and open up my Linux box here. And let's clone this repository here. So all right. Oops. All right. Okay, let's take a look here. I don't know if there's any setup needed. Yeah. Oh, you know what? We can just install this using pip, so that's all we'll do. So we don't even need to clone this. So I'll just do, I'm going to create a virtual environment here. You don't have to do this. But I'll create a virtual environment, activate it, and then we'll do pip install. And just like the repository says, Mersenne Twister Predictor. And we'll go ahead and install that pip package. Come on. There we go. All right, and then now we should be able to run MT19937 predict if this installed properly. So let's come back here, take a look. Okay, so yeah, looks like that did install. Is expecting some sort of input. So what they're doing here is they have a file with 624 values in data.txt. They're catting that, piping it into the program, and then putting the output into predicted.txt. And that's pretty much exactly what we want to do. So let's go back to Visual Studio Code. One very important caveat that I'll mention. If you try to view the source for this on the impossible level, in Edge, it's going to give you this error. If you try to do it in Firefox, it'll actually show you the source, but it will reload the page. And reloading the page is going to give you completely new random values. So you may think you're looking at the source for this page, when in fact you're looking at the source for a completely new iteration of the game, which if you try to then take back to your first iteration of the game and beat it, you're not going to be able to, because you're going to have the 625th value predicted for a different instance of the game, which is going to be completely different. So just be aware of that. The best way to get these, the correct values out of the comments is to use the developer tools, whether in Chrome, Firefox, Edge, whatever, and extract them right from the via inspection of the current page. So that's a very important caveat. That screwed me up for a while until I realized what I was doing wrong. Okay, so let me just copy these out again, just because I'm paranoid. All right, so we're going to go ahead and clean this up so just the numbers remain. I'm sure some of you are going to laugh at me, but because I'm sure there's like easier ways to do this. But we'll just go ahead and not random enough, and we'll do a replace with nothing. Okay, boom. So now we have all of our values, 624 of them. So let's take that, copy that, and we will mt.values. Okay. Oops. And we'll paste all 624 values in there. You could do wc word count -l for to count the lines in a file, and we can verify that it's got all 624 integers in there. Now, an important thing with the Mersenne twister is it expects 32-bit integers as its input. I will say I looked at each of those values, and they all do fit in a 32-bit integer. So this challenge makes it easy for you. There are, later in a later video, level or objective 11, we're going to have to modify that because the values that we get, spoiler alert, are 64-bit integers, I believe. But this is what the game is outputting is 32-bit integers, which the Mersenne twister expects. So we can just feed them right into this program and get our 625th value out. So what we're going to do is cat this empty values file, and then we'll pipe it into the MT19937 predict program, and let's see what it gives us as output. Right, so this is actually predicting a whole bunch of values. We only need one. So what we're going to do is this command, running head with -n1. That's only going to give us the 625th value rather than just generating new values indefinitely. Okay, so now this is the current user player name that is being used for this impossible game. So being very careful not to close this tab, we are going to want to start a new game. And we're going to want to go on easy. Oops. And we're going to want to take our 625th predicted value from here and paste it into the easy level and click play. So what we're going to want to do now is play through the game, and right before we finish, take a screenshot of all the hits that we have. And then we're going to take that back to the impossible game and replay our hits, and we'll win the game and complete the challenge. And the reason we complete the challenge is because, like I said, the impossible enemy knows all of your locations exactly. And so we need to know all of the hits exactly for the enemy to be able to beat that AI, if you want to call it AI. All right, so let's just go through, play this game. And like in the easy game, the AI whatever is pretty dumb. Like it's only got one hit so far. If we were impossible, it would have however many hits that correspond to the number of plays that I've had. So we'll just go through this here. Kind of feels like Minesweeper a little bit. All right, there we go. Okay, so now this 1, 2, 3 forts. Oh, here's 5. Or 1, 2, 3. Here's 4. Okay, so now we have one more to hit. Okay. So we're going to want to start taking screenshots here. Just so we know, because I'm not sure if the fort is 1 or 2. Okay, so this is the only other value that it can be for the fort. So once I hit enter, we're going to win the game, and we want to make sure that we have a screenshot of this at the ready so we can reuse it. Oops. Okay. All right, so we've won. Okay, so this now, including this square, this is our exact hit layout. So let's open this up next to the impossible game, and now let's play it out. Now be really careful, don't miss anything when we're inputting stuff. Because if we do, we're going to have to restart this whole process again. 7, 5, 7, 6, 7, 7, 5, 5, 4, 5, 3, 5, 2, 5. The concentration is real. And then finally, win. And you know what I didn't do? I did not do it in this, which means we don't win. So, okay, so basically, just remember that you have to come into this iframe, whatever you want to call it, inside the actual, KringoCon game in order to win it. So, you know that now. If you want to stop watching, that's fine. Otherwise, I'm going to continue on, just repeat this really quick with this game. So what we'll do is go back here. Okay. And let's launch an impossible game. Play. Nope, we don't want to do that. We want to inspect. And we want to copy. Remember, we have to copy while we are inspecting, because if we viewed source and launched another game, we would have completely incorrect values. Okay, so go ahead and yeah, I gotta clean those up again. All right. Right. 624. Bring it back into here. And paste those out. Check the word count. And get the 625th value. Take this value. Oops, I got so many windows open. Be careful to not close anything out. Come into easy, paste that value into easy, and play this game real quick. That's 1 fort down. That's 2 forts down. Boy, these are not easy to find this time. Oh, that's 3 forts down. That's 4 forts. That's 5 forts. Sure we get these latest values here. Okay. Come on. All right. All right, and then also this one. Okay, so now we come back to the actual in-game version, not the expanded one outside of the regular game. And let's go ahead and input these. Oh, and this one. Boom, win. Okay, and then we get the achievement, and then I'm sure this will give us some hints. Okay, and it does. Yeah, so this gives us actually some important hints for the blockchain challenges, which we will look at in a later video. Thanks for watching. Let me know if you have any questions, and I will catch you in the next one.